Hello. Okay. Click a... damn. Right, yes, my name's Leon. That was a bit of a lie. I didn't set my friend's house on fire when I was a kid with a firecracker. I set my friend's house on fire when I was an adult with a homemade firework. So yes, I'm Leon, I'm drunk, and I'm here to talk about Moonbase. Also, I'm not drunk. I'm British. So, before I begin, a special thanks to three people that really helped make this talk a reality. One is Benton Green, one is Joe Lindgren, and the other one is Humboldt Mandel, who some of you may have heard of, and also to the internet for 1 billion images. I have about 140 slides to get through in 15 minutes. Ha ha! That's not a joke. Okay, so, humanity have always been explorers, and for us today, that means going to space. Rather fitting, perhaps, the final frontier. It is a vast and infinite ocean. An ocean, in fact, that we haven't gone very far into. The furthest a manned mission has ever gotten into space is to the moon, and the last time we did that was in 1972. And in fact, our current manned mission into space is the International Space Station. I'm going to put this over here. A program that we pretty much finished building fairly recently. It took us 20 years, and it cost us about $100 billion. Now that's quite a lot of money, and this is the problem with manned space missions. They are so expensive, it pretty much prevents you from going anywhere else to boldly go on a budget. $100 billion is a crazy amount of money, and as critics of the International Space Station and the space program in general have pointed out, for $100 billion you could employ 100,000 scientists to do a great deal of stuff. And if you think we got more science out of the space station than we would get out of 100,000 scientists, I would guarantee you that you are wrong. So what did we buy with our 100 billion? Well, we bought a number of things. One is we now have actually quite a good idea about what it takes to survive in orbit of the planet, and the other one is we actually have quite a good idea of how you get a very large amount of mass into low Earth orbit. What is special about low Earth orbit? Well, low Earth orbit puts you about 100 miles above the surface of the Earth, doing about 200,000 miles an hour, and the nice thing about that is really you are halfway to anywhere. There is a saying in rocket science, if you are in orbit, you are halfway to anywhere, because it's really hard to get anything into orbit. But the nice thing about being in orbit is that a little bit of a push, a relative little push to 20,000 miles an hour, sees you shooting off into the solar system, slow down a little bit, and you return, you hope, safely to Earth. The problem about getting to low Earth orbit, though, is that it requires a rocket, a very big rocket, a very expensive rocket that weighs an incredible amount, but actually takes a very tiny amount to orbit, almost 4%. And this is the problem with going to low Earth orbit. It requires huge, expensive rockets to take relatively tiny amounts of mass into orbit. Here is an analogy. You live on the tiny bank, or the bank of a tiny river that empties out on an ocean, and you hear about this fantastic faraway place that you would like to visit. The problem is that big seaworthy ships don't do very well in tiny rivers, and so you are forced to build a tiny little ship that you get over to the edge of the ocean. Tiny boats don't do well in vast oceans, and our boat is so very tiny, and our ocean so vast. But nonetheless, here we are. Now, after the advent of the ISS, it's still going on, but we pretty much finished building it. We have the technology now to survive for periods of time on space on our own. So it begs the question, where do you go? Some people, they want to go to the moon. Some people, they want to go to Mars. A lot of people are floating ideas around. The problem is that at $100 billion to pretty much do anything, or thereabouts, if you do one thing, it stops you from doing another, because the budget really only supports one manned mission. And it's fair to say that humanity has quite a love affair with Mars. You know, we've got a lot of this sort of thing going. We sent a whole ton of probes, so many probes. We've got some absolutely gorgeous images. And we know actually an incredible amount about Mars. Now, if you compare that with the moon, well, what have we really got? It's a bit grey. We've already been. It's kind of boring. I mean, you've played golf on the moon. If you've played golf on the moon, to be honest, it's time to go and play golf in new and interesting places. And in fact, so committed are we to playing golf in new and interesting places that NASA has even written the Design Reference Architecture, the DRA, and it's very long and talks about how it is we're going to put people on Mars. This is the short version. You are here, you want to be there. Okay, so how do you do that? Well, if that's the Sun, and this is the Earth, and that's Mars, and this is their respective orbits, so you start off orbiting Earth, right? We've got the ISS, that's our technology. We're in a tiny boat moored up to the edge of a giant ocean. Okay, well, and you want to be there. It's a very long way away, 250 million miles, in a distance that makes any sense. That's about 280 days, which is a bloody long way to go in space. And so what you do is you fire off a bunch of rockets, bish, bash, bosh, and you find yourself pretty much over at Mars. I must admit I simplified that a little. And now you're orbiting Mars. Well done, job done. It's not quite done yet. So first you drop yourself down on a lander, you build a base, huzzahs, you stuff your pockets full of Martian rocks, you play a bit of golf, you jump into your ascension vehicle, you go back to orbit, and now you have to go home because you're at Mars, Earth is over there. And that's quite a long way. And this is all very exciting, of course. You end up with a pocket full of Martian rocks. You probably don't find any life, whether it's there or not. And if you're really lucky, nobody dies. That wasn't a joke. The Moon, on the other hand, is a much more sort of civilian, pedestrian affair. It's quite straightforward. You are here, and thankfully, so is the Moon. If this is the Earth and that is the Moon, well, it's only a meager 240,000 miles away, or 2 days in actually any real distance, which is less than 1% of going to the Mars, which actually is really helpful. Nonetheless, the idea is the same. You start in orbit in Earth, you fire a bunch of rockets, and then you get to the Moon. Great, you land, you build a base, you stuff your pocket full of Martian rocks, you play a bit more golf, perhaps an 18-hole, who even really knows. You get back into your lander and you fuck off home. Job done. You've got even more rocks than you have already. You've got an even lower chance of finding any life, but on the plus side, odds are good that nobody died. But the reality is when you compare both of these missions, they're always kind of similar. People talk about doing the same mission to Mars or the same mission to the Moon. You're really talking about building some kind of equivalent to the International Space Station just on the surface of something. And so when you do the costing on that kind of idea, well, going to the Moon is about 4 billion, going to Mars is 6 billion. These numbers change. It all depends on how many rockets you want to launch, and Mars is further away, more rockets. But the reality of this situation is, despite the difference in cost, the R&D, the research and development cost for either of things is huge. And what that means is they're basically the same price. You want to build some kind of Mars base, you want to build some kind of Moon base, it doesn't matter, they cost about the same, because the cost of developing the technology to survive on either of those environments is much higher in some senses than building the rockets. And so when you sort of do this math, you're like, well, clearly I want to go to Mars, and even if you consider that you run an original mission and then you do 2 resupplies, so 3 in total, you go to a place 3 times, you sift around in the dirt, you nick some rocks, you look for life, you do a lot of science communication. Even so, if you go 3 times, that's a lot more rockets to get to Mars, but after the huge R&D cost, Mars winds up being about the same, and so in that sense, it makes a lot more sense to go to Mars, right? It's a more exciting place, there's kind of more science to be had, etc., chances of life, red planet, something, something, something. You can tell I'm a fan. The cost of doing this, though, is extravagant. I don't know if it would be around 100 billion. In truth, you'll hear all kinds of numbers, but nobody really knows what it costs to do it until you go. I would hate to think what people promised the politicians the ISS would cost. I bet it wasn't 100 billion. Sorry, fuel for the rocket. And so generally when you speak to people, you know, the public, so forth, the Moon's kind of boring, Mars is real interesting, and that's kind of where you want to end up going. And this is the issue always with these projects, is that they're so expensive that despite what Elon Musk might tell you, it is the public that ends up paying for these. He's not launching rockets on his own money. NASA is giving him money to launch rockets in the hope that they end up being cheaper than it would cost NASA. And so in that sense, you kind of hit this stumbling block that NASA is asking for a Mars base because it thinks it might actually get approval for a Mars base, right? Because ultimately public projects are approved by public figures. Yay. Public figure. I don't even get to vote. I don't care. Public figures who are perhaps a little bit guilty of giving the public what they want, but if I had asked the people what they wanted, they would have asked for faster horses. And herein lies the problem, right? Because if you take a step back and you think about why did America go to the moon, right? And the simple answer is that it was a giant dick swinging contest for a nuclear arms race. But then if you ask the question, why did you go 6 times? Because 2 is enough. Just, that's enough dick swinging. Right, 2, you've proved, don't worry. Why the other 6? And this is kind of where the science comes in, right? Did we go for iconic photographs? Did we go from, to build our moon rock collection? Did we go for one small step for man? No, I don't think we did. I think ultimately, at the end of the day, we went for the question, right? It's the question that drives us. We are explorers after all. And the thing with the question is it never has a good answer. For instance, you might say to yourself, what is the moon made of? Right? Oh shit, problem solved. All right, goodbye. No one tell NASA. Okay, so you might say to yourself, what is the moon made of? And you say, okay, well, that's easy enough to ask. Just build yourself a rocket, fly to the moon, scrape up some rocks, come home, have a look at them. And if you do that, it turns out that the moon is made of exactly the same thing the Earth is made of. Actually, the moon is actually made from the Earth, as best anyone can guess, which is a wonderful answer in some senses until some bugger asks why or how. How is the moon made of the Earth? Why is the moon made of the Earth? Well, fuck. Now you have to go back. You never go once. You don't go 5 times or 10. You don't go 100 or 1,000. I mean, it's not like any of the early explorers just popped over to America. We're like, oh, this is quite nice, isn't it? Oh, it's spicy. You go home. No, that's not what you do, right? You have to build infrastructure. You have to have this idea of what you want to do. And this whole ethos, it's hinted to on page 4, if ever of you ever feel like reading it, the Mars Design Reference Architecture. Page 4 is a quote by Bradbury. Silent B. We are all children of this universe, not just Earth or Mars or this system, but the whole grand fireworks. And if we are interested in Mars at all, it is only because we wonder over our past and worry terribly about our future. And I must say, I do worry. Because I worry when people show me this image and tell me that it costs the same, or costs about the same to go to Mars as it does to go to the moon to build the same base, that we've really got the wrong idea. You see, the logic behind this idea is that we go to both, and you either go to Mars and build what we think we can kind of get away with, which is on the right, or we go to the moon, but then build the same thing we would have built on Mars, and that doesn't really make any sense. What if you're willing to say, okay, well, I've got a whole bunch of money that I might have spent over the next 20 years, and I'm willing to throw that at the moon. What can you buy yourself then? Okay, well, we got 13 billion at the moon, that's 26 rockets, which winds up about being 14 more than we really need to just put something real basic on the moon. If you want to go to the moon, it winds out, it's real hand-wavy. 14 rockets will get you about 100 tons. That's 1,400 tons, which, in case you didn't hear me the other time, is 1,400 tons. That's an incredible quantity of weight. For some idea, 1,400 tons, the base you're likely to originally land probably weighs less than 100. That's an incredible quantity of weight. So here's a proposition about what we could do with that extra weight. We could bring a space drill. A space drill that's powered by electricity because you're on the moon and you have sunlight and electricity is basically free. And you could start to dig into the lunar surface. And you could build yourself an underground space base, and this works real well because underground, you're protected from the radiation, you get a lot of structural integrity from the holes that you dig. There are a few kind of problems you have to overcome, but nonetheless. And do you remember how I said the moon was made of the same thing the Earth is made of? Well, that's real convenient because theoretically anything that you can make on Earth, you can also build on the moon. And so you bring yourself an electric arc furnace, which I like to call an electric space forge. And you put the electric space forge in your base. You might need a few more solar panels, but who knows. And the moon, as it turns out, at various places is quite rich in iron, silicon, aluminium, and titanium, all of the kind of basic building blocks you need for a lot of stuff. And this allows you to build tools to start with. And once you start building tools, you can make better tools, and then eventually you end up making more moon-based, but you get to do it on the moon. You see, you don't have to do that first half, that halfway to anywhere. You get to do it exactly where you are. It only costs you people. It's much easier to do. And so now you have this kind of orbital space factory. And once you're done building moon base, you can start building other things like satellites and rockets. Nice thing about the moon as well, as it turns out, we have a pretty good idea. It's got quite a lot of water on it on the poles, as it turns out. People can argue with me later. Water is fuel. You split water, hydrogen, oxygen, that's rocket fuel. So now you have an orbital rocket factory. Water equals life, so now you can have a space farm. Won't that be fun? You can make oxygen and food, like on the moon, right? So now you want to do a mission anywhere in the solar system, all you need to do is bring people, because you have food, spaceship, everything just sitting on the moon. You can also make plastics out of plants, that's quite helpful. Have anyone heard of a railgun? These are fun. These are giant electric cannons, able to fire things at thousands of miles an hour. You could probably build one of those on the moon as well. I'm sure that wouldn't upset Russia. It'd be fine. Now you've got a railgun. Do you remember how I said getting to orbit was halfway to anywhere? Now you have an orbital spaceship factory and launch site. See, satellites aren't hard to build. They're just difficult to place. CubeSats are made by students. Students. You can just sit there with a catapult, just firing them out into the universe, just throwing them. You don't even have to aim at this point. They're so cheap. They're so easy to make. You're like, where is Jupiter? Or over there. At almost no cost. The cost is some bastard to make them. You're just going to pay someone's wages. That's it. When you're building them on the moon, because it's already in orbit. It is the equivalent of hearing about some faraway fantastic place on the edge of a river and sailing your crappy boat down to the ocean front, where you build a port. And at the port you build a genuine, seaworthy vehicle that you can use to go to places that you are interested in. Because fundamentally, this is the problem, in some senses. This talk is not about the specifics of a moon base or of a Mars base. That's not what this is about. This is about whether or not we want to spend the next 20 years investing tens of billions of dollars essentially in a project that goes somewhere and brings back a few rocks and answers a few questions which will ultimately just lead to more questions. Or whether we want to invest, perhaps, that money building genuine infrastructure within our solar system that allows us to go further. But the problem is the moon is not sexy. In a weird, kind of nebulous way, it is us, the general public, that gets to decide actually where we go via our wonderful politicians. And so in some senses, this talk is about letting you know that there is another option that isn't about just running one-off missions. It's about doing something a bit more substantial. Because for a reason that really escapes me, people think the moon is boring, but I could think of nothing more inspiring than all of humanity being able to stare up at the crescent moon, at the line between light and dark, and seeing man-made light from a man-made base pushing out into the darkness. And so with that in mind, project. With that in mind, next slide. With that in mind, I leave you with this quote. If you wish to build a ship, do not divide the men into teams and send them into the forest to cut wood. Instead, teach them to long for the vast and endless sea. Thank you very much.
Questions? Right here.
Pardon? Okay, so the question is, the moon is so interesting, why haven't we gone back? The budget is to be frank. Before the ISS, there wasn't really the technology to go anywhere that wasn't basically near-Earth orbit. And the nice thing about near-Earth orbit is if it all goes wrong, you just jump out. We didn't have the technology, and if you don't have the technology, you have to pay more money. So, we just weren't at a place where we could even contemplate that, to be honest.
Back here.
What about
Yeah, there are. I mean, if you read the DRA and various things, there are a number of sections where NASA and various groups talk about testing various pieces by landing on various stuff. Your problem there is that you're still not really building any infrastructure, right? You're still trying to sail your tiny crappy boat through a huge ocean, which in this case is full of radiation and things that will kill you. Instead of simply taking the safer, less interesting option of going somewhere close that you know you can do and building some genuine infrastructure. Instead of it's not as exciting, granted, but it gets you a lot further in 20, 40, 50, 100 years.
Right here in front.
Since both of us have had at least one beer too many,
Yeah.
what about not using rockets? What about the elevator concept to reduce or to improve the efficiency? You talked about 4% of the mass of the system gets into orbit. Elevators promise to be more efficient. What do you think of that?
Yeah, so rockets are real shitty. They're an awful way of going to orbit, but it's pretty much the only way you've got. And as this gentleman correctly points out, an elevator would be great. The trouble with an elevator is it has to bear a lot of its own weight. And as I understand it, even theoretically speaking, the only thing capable of holding up an elevator of that sort of size would be carbon nanotubes. And even then, that's questionable. So, I mean, a brilliant idea. If you do the math, it costs you about $10 to go to orbit as long as you bring something down of an equivalent weight with you. You know, it's like an electric motor going up. It's a generator coming back. So as long as you've got the same mass, it all works out. But, I mean, again, you're working with the best engineering you have, which doesn't deal with space elevators or anything like that. So.
Up top.
When you're talking about students building CubeSats, when did the CubeSat be on the moon?
I would be okay with that.
I'll volunteer. Back here.
Okay, so if I buy it, how do we make the moon sexy?
And Summers. I don't know. That's up to people. I can't answer that one. All I can do is try and give you the options. For me, the idea of having a giant orbital space factory armed with a huge, great big electric cannon capable of firing things at tens of thousands of kilometers out into the solar system sounds pretty fucking sexy to me, versus a pissy little red base. But I don't know. You tell me. How would you know? This is the problem, right? It isn't the most favorite option, and you genuinely do get funding based on, in some senses, what politicians will approve.
You just described American politics.
Just say they lied.
Pardon?
Just say they lied. That's
All right, last question. Back there.
Why not instead of making the virtual thing, use like asteroid redirect methods to make a giant orbital base with a railgun and you can shoot things up. And then you can make spaceships out of an asteroid as well.
Okay, so I don't know if you've been watching the news recently. SpaceX hasn't had a great time of things. And let's talk no more about the Chinese Space Agency. So how do we feel about bringing an asteroid intentionally very close to orbit? Do you remember how I mentioned how easy it was to just, it's in orbit, oh, it's not in orbit, oh, it's retrograde, oh, that's the problem. So you could, right? But I mean, in some senses, the moon is a giant asteroid. It's a giant lump of raw materials that's already orbiting our planet. It's very stable. It's very large. It's a third the diameter of the Earth. In some senses, it's the largest thing you will ever see with your naked eye. Why bring an asteroid? You can just go there. It's full of iron. It's full of all the things you need to build stuff out of. And we've landed there. We know how to do it.
All right, I was told I can do one more question. In the back row right here.
So sorry, you said if I was on the moon, could I come back to Earth? Yeah, so I skipped over an incredible quantity of detail. Generally, the idea is that you use the railgun, so firstly, to avoid some political consequences, you set it up on a place on the Earth that would make it very difficult to fire it anywhere on the Earth. And then you fire it in alternate directions. So you fire it one way, because you've got conservation of momentum, right? You fire something real fast. If I jump in the air, for as long as I'm in the air, I push the Earth down some amount. So I fire something off in one direction. You're right, that will start to spin the moon in the wrong direction, essentially, or in the opposite direction I fire. So if I just fire the opposite way the other time, it keeps balancing out. Even if you're just firing duds off to balance your momentum out, there is a way, yeah, you can conserve the rotational spin of the moon by managing that. Or you can not care, I mean, it's pretty big. I mean, guys, global warming.
That's another talk.
For my second talk.
All right, everyone, let's thank Leon one more time.